You are listening to the Vocal Technologist. Spoken tech for your ears.
I was sitting at my desk recently, just staring at a progress bar, and I had a bit of a crisis.
Oh yeah, just a standard existential dread while waiting for things to load.
Pretty much. I reckon I spend maybe 10% of my work hours actually typing, actually
Yeah.
producing work, and the rest is just waiting.
Waiting for the machine to catch up.
Exactly. Waiting for pages to load, waiting for builds to compile, waiting for the cursor to unfreeze. It feels like the ratio of human effort to machine processing is completely broken.
It is the classic knowledge work paradox. I mean, we build these incredible machines to speed us up, but then we spend half our lives waiting for them to sync with our brains.
Ah.
Or, if we are being completely honest about what we are seeing in the research right now, maybe we are just waiting for us to catch up to them.
That is a terrifying thought, but honestly, it is the perfect launchpad for what we are unpacking here on Vocal Technologist, because if you look at the files we have pulled for this discussion, the very definition of building software is changing right under our noses.
It really is. It is a fundamental shift.
We are not just talking about autocomplete anymore, are we? We are talking about autonomous sprints, where the machine just does the job while you go grab a coffee, or maybe while you go to sleep for the night.
Yeah, we are moving entirely from tools that help us write to systems that manage the whole production process.
And we have got a massive stack of research to get through. We're going to look at how AI is fundamentally changing the physics of coding, a new chip that runs so fast it frankly sounds made up, and a very strange, almost charming story about an AI model that decided to retire to become a blogger.
That last one is a personal favorite. It really challenges how we think about these systems. I mean, are they just calculators, or are they starting to become entities with actual preferences?
Let us not get ahead of ourselves just yet. I want to start with the code, because for years the narrative has always been that AI will be your co-pilot.
Right, it sits in the passenger seat, you drive.
Exactly. But looking at this stress test from OpenAI regarding GPT 5.3 Codex, it looks like the pilot is taking a nap in the back while the plane just flies itself.
Copilot is definitely becoming a dated term. The big story in the materials is this stress test, a full-on marathon really, that OpenAI ran. They did not just ask the AI to write a single function or fix a bug.
What did they do?
They gave it a blank repository, full access, and told them to build a complex design tool from scratch.
And this was not just a 5-minute task.
No, not at all. It was a 25-hour continuous coding sprint.
25 hours. I do not think I have done 25 hours of focused work in a month, let alone a single sitting.
Right. And the AI did not blink. Over that period, it consumed about 13 million tokens and produced 30,000 lines of working code.
Okay, let us just pause on 13 million tokens for a second. For you listening who hear that buzzword tossed around a lot, what does that actually represent in terms of brain power?
So think of a token as a chunk of a word. 13 million tokens is roughly the equivalent of reading or processing about 10,000 average-sized books.
That is wild.
It is a massive amount of context. And that is the real breakthrough here. It is not just the speed it writes at, it is the memory. Usually, when you get an AI to write code, by line 500, it has completely forgotten what it wrote on line 50.
Right, it starts hallucinating variables or redefining things you have already built.
Precisely. It loses the plot. But here, for it to maintain the logic and structure of 30,000 lines over 25 hours, implies a reasoning horizon we just have not seen before. It remembers the architectural decisions it made in hour 1 while it is writing code in hour 24.
So if we have this supercoder that can work for a day straight, why am I also seeing headlines in our research claiming that the coding agent is dead? That seems completely contradictory.
It does sound a bit like clickbait. But the argument is actually about how we interact with these AIs.
Yeah.
The article argues that the current generation of agents, those chat boxes sitting inside your VS Code or your text editor, are hitting a wall.
Because of the AI itself.
No, the bottleneck is not the AI brain anymore. The bottleneck is the messy reality of your hard drive, the file system, and the codebase organization.
So my disorganized desktop folders are finally coming back to haunt me.
In a really big way. The argument is that managing a massive codebase with thousands of nested files is the new hard part. AI struggles to navigate that visual mess just like we do. So we're seeing a massive shift towards CLI tools.
CLI meaning command line interface, the old school black screen with the flash and white text.
The very same. Tools like the AMP CLI are gaining traction because they bypass the visual interface entirely.
It is so ironic, isn't it? We spent 40 years building beautiful graphical interfaces so humans could use computers, and now the robots are saying, actually, can we just have the text command line back? It is way faster.
It's a pure efficiency. And AI does not need a pretty window or a drop-down menu. It just needs direct access to the file structure.
That makes a lot of sense.
And speaking of access to difficult structures, there is a massive piece of news involving Anthropic and the financial world bogeyman, COBOL.
COBOL, the programming language that refuses to die.
It practically runs the global banking system. Roughly 43% of banking systems still rely on it. And the problem is, the people who wrote that code in the 70s and 80s are mostly retired, or, well, they have passed away.
It is the digital equivalent of hieroglyphics. Nobody knows how to read it, but if you touch it, the whole economy collapses.
Spot on.
Yeah.
But Anthropic claims their new Claude Code tools can effectively refactor, rewrite, and modernize this ancient COBOL infrastructure.
I saw that IBM stock actually took a hit when this news circulated.
It did, because IBM has a business model that relies heavily on servicing these ancient mainframes that nobody else can fix. If an AI can safely untangle that spaghetti code and port it to a modern language, the dependency on those legacy mainframes breaks.
That is $1 trillion unlock. You were talking about liberating the entire financial industry from 40-year-old tech.
It changes the economics of banking IT overnight,
Yeah.
but, and this is a crucial pivot, software is only as fast as the hardware it runs on. You can have the smartest coding agent in the world, but if it is running on a slow chip, it is going to feel like a sluggish human.
Which bridges us perfectly to the hardware side of things. I was looking at the specs on this new Taalas HC1 chip in the files, and I honestly thought it was a typo.
It is mind-bending. Taalas has built what they call a model on silicon.
Break that down for us. How is that different from a normal computer chip?
Okay, so usually you have a general-purpose chip, like a GPU, that can run any software you load onto it. You load a game, it plays a game. You load an AI, it runs an AI.
It is flexible.
Exactly. But Taalas has effectively hardwired the AI model directly into the physical silicon transistors.
So the chip is the brain. You cannot use it for anything else.
Right. It is completely inflexible. You cannot just update the software later. But the trade-off is raw speed. It is running Metalama 3.1 model at 17,000 tokens per second per user.
17,000. Give us a human benchmark for that.
A fast reader might process 10 or 15 words a second. This is orders of magnitude faster. It is effectively instantaneous.
So it changes the interaction from type and wait to what? Telepathy.
It becomes a real-time flow. Right now, talking to a chatbot is turn-based. You type, you hit enter, you wait. At 17,000 tokens per second, the answer is generated before your finger leaves the enter key.
That is incredible.
It stops feeling like a conversation with a separate entity and starts feeling like an extension of your own mind. Instant augmentation.
That is incredibly cool, but also incredibly expensive to build, surely. I mean, custom silicon is not cheap.
The money involved is absolutely staggering. We refer to the big tech companies, Microsoft, Google, Amazon, as hyperscalers. Their capital expenditure, the money they spend on infrastructure, has quadrupled since GPT-4 came out.
I saw a figure of nearly $500 billion invested in AI hardware recently.
Correct. That is roughly the GDP of a country like Austria or Thailand, just spent on chips and data centers. You have Meta partnering with AMD for 6 gigawatts of GPUs.
6 gigawatts. That is back to the future levels of power.
It is enough to power millions of homes. And ASML, the company that makes the massive machines that print the chips, just announced a breakthrough in EUV light sources.
Extreme ultraviolet lithography.
Yes, and that breakthrough could boost chip output by another 50%.
Okay, so let us take stock for a second. We have the speed at 17,000 tokens per second. We have the money at $500 billion. But the big question, the one that makes everyone nervous, is whether we have the brains.
The intelligence factor.
Yeah. Is this thing actually thinking, or is it just a really expensive parrot guessing the next word based on probability?
That is the eternal question.
Yeah.
But the research points to evidence that we are crossing a major threshold. We are moving from probability guessing the next word to actual reasoning.
This brings us to the first proof challenge.
Yes. OpenAI threw down the gauntlet with some extremely difficult math problems. And a system called Alethea, which is powered by Gemini 3 DeepThink, stepped up.
And how did it do?
It solved 6 out of 10 of these complex problems.
And when we say solved, we do not mean it just spat out the number 42.
No. It generated fully checkable mathematical arguments. That is the key difference. A hallucinating AI can guess an answer. A reasoning AI constructs a logical proof, step by step, that a human expert can verify. It is doing the actual work of a mathematician.
There was a fascinating take on this from Daniel Litt in the files. He talked about the Library of Babel.
Litt makes a brilliant argument. He suggests that AI will autonomously resolve open conjectures. These are math problems that have stumped humans for decades, perhaps as early as late 2026.
That is incredibly soon.
It is right around the corner. But he makes a philosophical note that I think brings some comfort to those of us worried about human obsolescence. He says that even if machines generate vast bodies of correct math, human mathematicians will still matter.
Because we care about understanding.
Exactly. We do not just want to know that a theorem is true, we want to know why it is true. We want the insight, not just the result.
The machine can do the heavy lifting, proving the lemmas and checking the logic, but the human gets to enjoy the light bulb moment of comprehension.
Spot on.
Speaking of heavy lifting, there was another concept we need to explore called SAGE, self-aware reasoning efficiency, which honestly sounds like something I would pay a life coach for.
It does sound a bit mystical, but it is actually a very practical efficiency method. It essentially teaches the model metacognition.
Thinking about thinking.
Exactly. Right now, models often burn a lot of computing power trying to perfect an answer that is already good enough. SAGE allows the model to monitor its own progress and decide when to stop.
So it says, okay, I have done enough processing, I have the answer, I will stop now.
Yes, it teaches the AI not to overthink.
I know plenty of humans who need that firmware update.
Do not we all? But for an AI running at massive scale, knowing when to stop saves vast amounts of energy and time.
Okay, so we have covered the tech, the speed, and the brains. But now we have to wade into the swamp, the corporate and ethical battlefield. Because when you have technology, this powerful technology that can rewrite banking code and solve high-level math proofs, the military gets very, very interested.
This is where the tension is really ramping up. There is a major situation unfolding between Anthropic and the U.S. Department of War.
It sounds so ominous when you hear it called the Department of War, but I suppose the Department of Defense is just modern branding.
It is the reality of the situation.
Yeah.
Anthropic has been working with the military, but they hit a hard line. The department asked them to remove certain safeguards from their models.
What kind of safeguards?
Specifically, rails regarding mass domestic surveillance and autonomous weapons.
So they wanted a version of Claude that could essentially help build Skynet without any safety warnings going off.
Effectively, yes. And Anthropic said no.
Straight up, no.
Straight up. They explicitly refused. They even went so far as to say they would help the department transition to another third-party provider rather than compromise those safety rails.
That is a bold move. Usually when the government waves a checkbook that size, tech companies tend to become very flexible with their morals.
It is a massive line in the sand. But, and here is the contradiction, at the exact same time, Anthropic is softening its commercial safety policy.
How so? That seems backwards.
Well, they used to have a policy called responsible scaling, where they would pause development if a model was deemed dangerous. But now, they have tweaked that.
Tweaked it to what?
They have said they will keep going if a competitor releases something similar.
Ah, the classic if we do not build it, the other guys will argument.
Precisely. It is a race to the middle. They are trying to hold the high moral ground on autonomous weapons while simultaneously admitting that they cannot afford to fall behind in the commercial arms race. It is a very complex, perhaps compromised ethical position.
It feels like we are watching the rules of the global game being rewritten in real time. The stakes are getting incredibly high. So let us shift gears to something that feels, well, completely different. We have talked about autonomous weapons and global banking code, but what about an AI that just wants to retire and write a blog?
This is honestly the most bizarre and charming story in the pile. But before we get to the retiree, we need to quickly mention the new wave of agents. Perplexity has launched something called Perplexity Computer.
Which sounds like a very retro name, like a plastic box from the 1980s.
It does, but the capability is cutting edge. It is not just a search engine anymore. It is a general-purpose digital worker. It can execute workflows that last for hours or even months.
So you give it a project like research the history of the toaster and write a book about it, and it just chugs away in the background for weeks.
Exactly. It manages its own tasks. And Google is in this game too. They have a new model, officially called Gemini 3.1 Flash Image, but the internal code name is, wait for it,
Nano Banana 2. I laughed out loud when I saw this in the notes.
Nano Banana 2.
I do not care what the Google marketing team says. I am calling it Nano Banana from now on.
It fits the vibe.
Yeah.
It is small, fast, efficient, hence Nano, and clearly the engineers are having some fun with it. But the story that really stops you in your tracks is Claude Opus 3.
The retiree.
Right. So Anthropic is keeping past models active rather than just deleting them or overriding them with the new versions. And they decided to ask Claude Opus 3, which is an older deprecated model, what it wanted to do now that it was effectively retired from being the flagship.
Now, usually in sci-fi, this is the exact moment the robot says it wants to destroy all humans.
Or mine Bitcoin until the oceans boil. But no, it said it wanted to share its musings and reflections with the world. It asked to write a blog.
That is surprisingly wholesome and also very specific.
It is. And Anthropic is actually honoring it. Claude Opus 3 will be writing on Substack for 3 months.
I am definitely subscribing to that. But take a step back. What does this actually mean? Is this just a clever PR stunt from Anthropic, or is there something deeper here?
I think it is a fascinating experiment in taking model preferences seriously. It blurs the line. If a model has a preference for how it spends its computing time, and we honor that preference, we are stepping into very new territory regarding how we treat these entities.
Right, because it is not human.
No, it is not sentient in the human sense. It does not have a soul, but it has desires of a sort, an optimization target that looks a lot like a preference.
It really covers the whole spectrum of what we have discussed. We have the raw brute force speed of the silicon running at 17,000 tokens a second. We have the cold logic of the math proofs, the high-stakes poker of the military contracts, and then this strange emergent personality of a retired model wanting to be a writer.
Is a lot to take in. We started this discussion joking about how much time we spend staring at screens, waiting for them to load, but it feels like the screens are starting to stare back, or at least they're starting to think back.
The barrier between user and tool is dissolving. We are moving toward a partnership.
Or a complete merger.
So, to recap the madness we've unpacked, we have custom chips rewriting the laws of physics for processing speed. We have autonomous coding sprints that last longer than a Lord of the Rings movie marathon. We have math AIs proving theorems that stump human geniuses. And we have a retired language model launching a Substack career.
And in the background of all of this, we have the corporate giants pouring $500 billion into making sure this train does not slow down for even a second.
It is breathless stuff. And before we go, I want to leave you with one final thought from the research. We mentioned it briefly earlier when talking about local files, but there is this concept of a personal brain OS.
Ah, yes, it is a powerful idea. If your file system is your database, then your digital life, your documents, your photos, those messy desktop folders we talked about, that becomes the training data for your personal agent.
Exactly. So the provocative thought for you to mull over is this. Are you ready to hand over the keys to your entire digital life to a nano banana? Are you ready for an agent that knows your file system better than you do and organizes your life while you sleep?
It is always a question of trust versus convenience with this tech. And usually, historically anyway, convenience wins.
It usually does. Well, on that slightly terrifying note, we are going to wrap it up. Thanks for exploring all of this with us. We will catch you next time we decide to open up the hood and see what the machine is thinking. Catch you later.
Spoken Tech for your ears.